Hello, everyone. Welcome to the 13th episode of Micro Minute. We are live now from ZEISS Microscopy Customer Center, Dublin, California. And even though it's 13, it's a very lucky episode because you will get to see multi-well workflows and experiments on the Celldiscoverer 7. So the CD7, as we call it at ZEISS, it's one of my favorite. Really, it's an instrument that can do everything. So it's an automated instrument, and without me having to bore you with a lot of slides and specs, let's just go right in front of the instrument at the lab. So just give me a second. I'm going to walk over, and then we'll do things live at the instrument. Hi, so I'm here by our instrument, the Celldiscoverer 7. And I am also joined by Michael, my colleague, who's helping film this. Thank you, Michael. So the first experiment, we are going to put down a 96 multi-chamber plate into the port here and do a couple of experiments from the TFT, this panel right here. So I'm going to put this plate down into this port right here and load sample from the TFT. So what it does, it moves the plate inside, and then it takes about 1.5 minutes for the instrument to automatically recognize the sample carrier, measure bottom thickness, tell us what the bottom material was. And while it does that, let's pan over to this table right here, Michael, please, and look at all of the different well plates that we can image on the CD7. So, for example, you can have a 384 well plate, a 1536 well plate, a 6 well plate, plastic as well as glass bottom. This plate has round bottom, and we utilize this for imaging organoids. Very recently, we have been collaborating with 𝗶হি𝗿𝗄 and imaging with their plates, spheroids grown in these plates. These are some of the 96 well plates that I utilize regularly, but I just wanted to point out very quickly the skirt height. So the skirt height is really low on this one, around 150 microns, and this helps the CD7 to image all of the wells in this plate, and it has automatic display visually for you to see how far it can image on a well plate. So I'll show you that in a minute. This plate has a higher skirt height, as you can see, so just wanted to point that out. So very quickly, the CD7 can also image slides, multi-chamber, and 35mm dish, but we might cover this on a separate YouTube channel. But for today, we're just going to image with multi-well and multi-chamber plates. So it looks like the instrument has done recognizing our plate. This panel right here has a drop-down menu of all of the experiments that have been configured on the instrument. So if it's an experiment that you run day in and day out, right, you could just select that experiment from this menu and click on OK and start experiment. So what you see happening up on the screen, Michael, if you can pan again on this way, you see the experiment start, and essentially what this is doing is I have one position per well in all of the 96 wells in the 96 well plate. And so it starts imaging just nuclei in this case. So I can do a 2-container view, and I can drag this over to just show you very quickly. It's imaging just a position per well and just the nuclei. So we'll just start very simple It's going to go image all of the wells, and it's just imaging one channel in 𝗶𝗵, and then it'll go on to do all of the 96. In this image that I already captured, all of the 96 wells captured for the 𝗶𝗵 channel alone. Now, manually, I could walk over to the analysis tab, and utilizing one of our cell count bioapp setting, I can apply a cell count analysis setting, run analysis, and get a 𝗶𝗵 count for all of these 96 seeds that we have captured.
Can you do analysis and acquisition at the same time from the TFT?
Good question, Michael. Let's test it out. So your question is, can I run an experiment from the TFT that combines acquisition and analysis all in one experiment with a touch of the button, right? Let's do it. Let's put this plate down. So I'm going to put the plate down here in this port and load the sample via this TFT tab right there. So this time around, I know that the sample I'm utilizing is a 96 multi-chamber, so I already told it the instrument. So I'm going to skip the step of the instrument trying to find the carrier and calibrating, so on and so forth. So let's do that. It's going to take about 20 seconds, and then once it's done, we'll pan over to the TFT and start the experiment that combines both analysis and acquisition. So right here, so you see this drop down menu. So I'm going to select the experiment per Michael's wish that combines acquisition and analysis. So I'm going to say OK and start experiment. So Michael, if you can pan over again to the software. So basically what it's doing right now is it has 6 positions that it's going to image in 3 channels, and this is the image that it's acquiring, essentially a 3-channel image with 𝗶𝗵, 𝗬𝗁, and PGC, which is a phase gradient contrast. So the goal here is to identify 𝗬𝗁 positive nuclei, which is labeled in red. So let it finish acquiring all of the images in the 6 positions, and then once it does that, what I have here is in the automation tab, I have a macro that will automatically apply an analysis setting on this image and give me a count of the H2B 𝗬𝗁 positive nuclei. So it applied the analysis routine, and if I should say show all my classes and fill, so you can see whatever is labeled in magenta are my 𝗬𝗁 positive nuclei, but very quickly I can highlight my nuclei. So all the 𝗶𝗵 are in yellow, and all of my 𝗬𝗁 H2B is in magenta. So it automatically applied that setting in my experiment. So I have one experiment that combines acquisition and analysis. So I hope that answers your question, Michael.
Yes, it does.
In the spirit of the micro-minute YouTube session, on my multi-chamber plate here, I have a 2x2 tile setup arranged in the letter M and M in these respective wells. And very quickly, I want to walk over to the sample tab to show you how the instrument automatically told me that this plate was a multi-chamber 96 well plate. The glass is the material, refractive index is 1.5, thickness is 173 micron, and it also automatically calibrated the sample carrier for me. All of this was done within 1.5 minutes of me putting the plate in the instrument. Walking over to the acquisition tab, I have a multi-channel experiment set up with 𝗬𝗁 labeling the H2B protein, in the nucleus, 𝗶, and then 488 is labeling EB3 on microtubule. It's a wide field modality experiment. So let's just start experiment, and I have definite focus engaged for focus strategy. So I'll say continue experiment, and it'll start acquiring data. I will do a 2-container view quickly and drag this image over here so you can see in a side-by-side view how it acquires data as it progresses through all of the tiled regions. So this experiment will go on for less than 3 minutes. And I might actually stop it right here because I have a data that I acquired previously and show you how that looks. So let me just stop that and go back to a 1-container view to show you this image that I just acquired. And I actually have a bioapps image analysis applied on this data set. But let's go back to the 2D view, and if I click on individual scenes, you can see individual scenes. But what is really cool in the latest version of this software is you can see the multi-well view. So the multi-well view gives you all of the scenes that's acquired in these letters M and M. And it also allows me to highlight wells. For example, I could highlight any of the wells that I want to compare and compare wells, and that gives me a very nice way to compare images in a side-by-side view. So over here, I just wanted to give you an example of cultured neurons grown on a 48 well plate. So as you saw in the video, we can image across multiple formats, so be it a 24, 48, so on and so forth. So this is just giving an example of neurons grown on a 48 well plate. And I'll just show you an example of a video playing from a Zen Connect project, which is essentially a project file that keeps all of the images in context from overview to detail. So what you see playing up on the screen is a neuron labeled in TD tomato. And as it zooms in and out of different wells, you see images that are overlaid with different modalities, from fluorescence to transmitted light to what you saw up on the screen was actually a LSM image. So this instrument can also image with the 𝗬𝗎scan detector. So what is fantastic is that you can resolve all of the spines in the neuron that's coming up on the screen right now. So in one video, you're able to convey your story of your entire imaging session from an overview image to all the way detailed. Now that's up on the screen is one single neuron that was imaged on the CD7 using the water immersion objective, which is the 50x with the NA of 1.2. And this one neuron was segmented using our 𝗬𝗎sS segmentation software. So what you saw playing was the segmentation with the 𝗬𝗎sS software. So with that, I would like to end this session and refer you to some of our upcoming workshops. So at ZMCC, we do have virtual and in-person workshops. So if any of the workflows that we just looked at interested you, we do have in-person and virtual workshops for the CD7. It's called Efficiency Unlocked. So please sign up for the skill builder workshops. You have the QR code up on the screen, or access all of our training resources that's on the ZEISS portal. And if you are interested to join us back live every Thursday, 1 p.m., that QR code on the right gives you all of the upcoming live streams. So every Thursday, one of us, application scientists, will be live in front of the instrument and help you answer questions. So if you have any questions, please feel free to type, and I'll take a look and I'll try to answer some of them live. Thank you for joining us.